Hi, everyone. Welcome to the special decarb panel hosted by Sibo. The topic of our session today is how to prevent quality, throughput, and energy losses in cement and glass manufacturing while keeping your carbon footprint low. The challenge of decarbonization is one faced by many energy-intensive industries. In today's panel, we have brought three experts in the cement and glass industries to share their thoughts and strategies on how to optimize their production processes to reduce emissions while maintaining or even improving overall process efficiency. Of course, across these industries and even within each of them, different manufacturers are at different maturity levels when it comes to this challenge. However, precisely for this reason, we believe that different industries can learn from each other, particularly when it comes to the use of industrial artificial intelligence. Our panelists today are Marcus Wrench, the technical director at Jura Management, part of CRH, a leading global cement manufacturer. One interesting fact about CRH is that some of their factories are actually operating today at 90% alternative fuel rate, and that's pretty amazing. Marcus, can you tell us a little bit about your organization and your responsibilities?
Yeah, CRH is one of the leading building materials suppliers in the world, employing about 76,000 people and is at more than 3,000 locations worldwide. We manufacture and supply a diverse range of building materials and products for use in the construction and maintenance of infrastructure, housing, and commercial projects. Jura is the Swiss subsidiary of CRH, serving the local market with cement, aggregates, and ready-mix concrete. And we are also engaged in the valorization of demolition materials and other sources of alternative raw materials. My role as a technical director is in the manufacturing of all those products, and I'm engaged in the innovation and in all improvement projects.
Okay, thank you. That was very interesting. I'll introduce our next panelist, who is Fabian Marion. He's the Technical and R&D Director, France at Verallia, a leading global glass manufacturer. And here's an interesting fact about Verallia, is that they have formulated a special three-stage strategy for decarbonization. We'll hear about that in a little bit. Fabian, can you tell us a little about your organization and your responsibilities in it?
Hi, everybody. Very pleased and honored to participate to this panel. Some words about the company. Verallia is a 10,000 people glass container company. We operate 58 furnaces in 32 plants in 11 countries, mainly in Europe, where we are the leader of the market, and in Latin America, where we rank second. Globally speaking, Verallia is the third worldwide, producing around 16 billion of bottled jars each year. Our target in terms of reduction of CO2 emissions has been defined and validated in last year by SBTi to comply with well below 2 degrees target. And we are committed to cut by 27.5% our absolute emission of CO2 on scope 1 and 2 between 2019 and 2030. My team and I are in front line in the action plan definition, one of our main activity last year, and now we focus on delivering through the action that have been defined. And we're also working on new ideas and solutions to make our action plan more robust, more economically efficient, and also to mitigate market growth, which seems will be higher than expected in the next years.
That's great. Thank you. It will be a very interesting conversation, I can tell by now. And finally, introducing our last panelist is Liran Akavia, who is the co-founder and COO of Sibo, the predictive quality and yield solution for continuous manufacturing. Liran, can you tell us about Sibo and the work you do around manufacturing?
Certainly. Thank you, Noah, and Marcus and Fabian. It's a great pleasure participating in this panel together with you. Thank you very much for joining. Sibo is a predictive quality and yield solution. We invented new technology. We call it process-based artificial intelligence. In order to provide value to complex industries like the cement and glass industries, it's not enough to be good in artificial intelligence and machine learning. You must embed the knowledge of the industry, the process knowledge into the algorithm. And this is exactly the technology we invented. This is exactly the problem that we are solving. Sibo answers the three most important questions for process manufacturing. We explain why process inefficiencies are happening, how to prevent them, and when is the right time to act. the Sibo solution performs automatically root cause analysis. We offer predictive recommendations and proactive alerts for the operators to know when to act.
Thank you. That is very, very useful, and it will come in handy in the rest of our conversation. So now on the main topic of our discussion, starting with cement manufacturing. The situation of the cement industry in Europe is quite different to the United States, particularly when it comes to decarbonization. In Europe, for example, cement manufacturers are already looking seriously at alternative fuels as governments offer financial incentives and regulations to encourage a move away from fossil fuels and towards more environmentally friendly alternatives. In the US, however, since there aren't any government incentives to use alternative fuels, the only way to stay competitive is to keep using coal. There just isn't a business justification to move to alternative fuels yet. These two situations require very different decarbonization strategies. So, Marcus, in your opinion, what are the different challenges faced by cement manufacturers in Europe and the US, and what strategies can they use to solve these problems respectively?
Yeah, you're right. No, the challenges are different between Europe and the United States, but in fact, the solution is the same, or at least very similar. I think important to say is here we are talking about the fuel-related CO2 impact, and not the CO2 impact that is coming from the transformation of limestone to clinker. The fuel-related CO2 impact is something every cement plant can actually start working on tomorrow. So in Europe, the challenge is to increase alternative fuel use while actually maintaining an efficient production process. This is a significant challenge because, first of all, alternative fuels aren't homogeneous and can cause a lot of instability, particularly at the kiln. This can affect everything from clinker quality and kiln throughput, also to energy efficiency. Second, the moisture levels are also unstable. If the moisture content is high, this also can negatively affect your kiln capacity. And third, the alternative fuel supply isn't consistent. So all these three elements can really affect the manufacturing process and make the process more unstable. This makes it much more difficult to control clinker quality, the kiln throughput, and many other of the key performance indicators.
So that's addressing Europe. What is the situation in the United States? How is it different?
Well, in the United States, the challenge is a bit different, particularly since there are far fewer government incentives to use alternative fuels these days, and fossil fuels are actually not very expensive. So, but there's still two elements I would like to mention here. First of all, it depends a bit probably where in the US you are. Certainly in more rural areas where there is a plentiful supply of fossil fuels and not so much political will or appetite for incentivizing alternative fuels, there won't be a financial justification for this. But in probably some more urban, liberal-leaning areas, there may well be the political will. And the second point is it's possible things might change under the Biden administration, which has made very clear its intent to go greener, but that remains to be seen.
Yeah. Okay, so I understand why there's no financial justification yet for American cement manufacturers to switch to alternative fuels, but is there any way for them to reduce their carbon emissions even while they continue to use coal?
Yes, certainly. Because most of the US cement manufacturers can still reduce both their emissions and clinker cost per ton by further optimizing their process.
Okay, so it sounds like there are major challenges in both cases. In Europe, they are moving towards alternative fuels, but are grappling with all the process instabilities and inefficiencies that causes. And in the US, on the other hand, there isn't much movement towards alternative fuels, but cement manufacturers are trying to lower emissions and be more energy efficient by optimizing their processes to use less coal. So the underlying theme is that process efficiency is the key, no matter where you are in this journey.
That's correct, Noah. Whether you are trying to use more alternative fuels or just be more efficient with using coal or gas, you need to better control and optimize your production processes to lower emissions, while still maintaining high standards in KPIs like clinker quality, kiln throughput, and so on. I would say to optimize your process in this way, you need probably three things. First of all, you need good people, teams who are talented, experienced, knowledgeable, and united towards these business goals. Second, you need process control and expert systems to help stabilize key points, assets within the process, such as the kiln and the mills. These are excellent tools, but they are limited because they focus on the asset, not on the entire process, and also because they still rely on the judgment and the calculations of your process experts. And then finally, there is the artificial intelligence, specifically the machine learning part, is emerging as a strategic way to manage these competing KPIs. The cement manufacturing process is very complex, and maintaining overall process optimization and stability is very, very difficult for humans to achieve on their own. Artificial intelligence and the machine learning can provide crucial insights into the optimum process settings to reach all those KPIs, from emissions to clinker quality, the kiln throughput, the energy efficiency, and the overall production capacity.
So what you're basically saying, Marcus, is that every cement manufacturer needs all three of these ingredients. They need good people, they need expert systems, and artificial intelligence in order to reduce emissions while maintaining overall high process efficiency. Liran, I think our audience will understand the need for good people and expert systems, but why do they need artificial intelligence? What can AI add that can be provided by, say, a really good expert system?
So you're right, Noah, and for many years, for decades, using smart and talented people, and later down the road, using expert systems and fuzzy logics and advanced process controls, the plants are optimizing the operation. Sibo is a decision support tool. At Sibo, we stand next to the operators and the process experts in their day-to-day process-related decision makers. At the end of the day, if you are a smart person controlling the line, or if you are programming a closed-loop control, you're taking dozens of process-related decisions every day. And during those process-related decisions, artificial intelligence could play a major factor. Let's see how. So at the end of the day, we are all interested in efficient production process. For that, we use expert systems or advanced process controls, and we use real-time, human-based process-related decision-making. The expert system is looking on a small part of the process, let's say the kiln or one of the mills. And the human is trying, at least, to look at the entire process. When we deploy an expert system, we perform research to build the logic and later program it into the controller. And also when we maintain it on a day-to-day basis, our maintenance and decisions are based on human decisions that are process related. So we can see clearly here that at the end of the day, even if we have an advanced closed-loop control and expert system, our plant depends on the human decisions. And exactly here, Sibo is supporting the plant. Exactly here, Sibo is supporting the plant. Let's see how the process-related decision-making is happening. So if I would like to perform a manual process decision, I have hundreds or thousands of different data types. And since I'm human after all, I'm selecting a few tags. I'm performing against those tags set of mathematical formulas. to calculate the tags. And based on that, I'm prioritizing decisions. The challenge with the traditional approach of process-related manual or human-based decision-making is here in the beginning, is when we make the selection of few tags. Here, as humans, we have blind spots. We have an assumption, and in order to validate it, we take few tags in order to validate, confirm, or disqualify our hypothesis. So the challenge here is that the data analysis is done manually on few tags, and the process related is based on human. This is an assumption validation only method, ad hoc analysis, and siloed. Now, when we look at those process-related decisions, we want them to be more complete and more automated. And this is exactly where Sibo comes into the game. We stand next to the humans when they take their decisions, and we convert their process-related decision-making to be automated and more accurate. So when we look back on the challenge in the process optimization, we know that we need skilled people. We know that an expert system could be a great help. And we know that artificial intelligence can help us take better decisions in a more automated way to run a more efficient process.
So it seems that the cement manufacturing industry has quite a wide variation in maturity levels. But some manufacturers are very advanced in the usage of alternative fuels in particular, and others much less so. But at the end of the day, no matter where you are in that journey, and no matter what government incentives exist for alternative fuel use, it's all about process efficiency. Now, let's go and do a shift, make a little shift, and turn to glass manufacturing. Fabian, I know that at Verallia, you take the mission of reducing carbon emissions very seriously, and you have formulated a strategy based on 3 core pillars. Can you take us through them?
Yeah, our first pillar is about raw material. Around 18% of our emissions come from decarbonation of raw material. To produce glass, we use sand, soda ash, and limestone. And each time we produce 1 ton of new glass, we have 180 kilograms of CO2 emitted. But glass is really a wonderful material because it can be recycled indefinitely. So please recycle and make people recycle glass. Recycling rate is really still low in the United States, which is around 1/3, while it's over 76% in the European Union. And target for Europe has been defined at 90% in the next years. So one of our big levers is to increase the cullet rate in our furnaces. That saves not only the CO2 emitted by the raw material decarbonation, but also energy. The more cullet you have, the less energy you need. Our furnaces with the lowest cullet rates consume 40% more energy than the ones with the highest cullet rate. And then after that, we'll look at renewable or non-carbonated raw material, and which we are currently working on. The second pillar is about reducing energy consumption, which is obviously the most virtuous pillar and probably the scope where AI will probably help us more. We define targets and action plans on both furnaces operation and for non-melting energy. We spend 80% of our energy in the melting process, but we did not dedicate as much time and effort in the past years on the non-melting energy, and the savings are easier than on furnaces. The third pillar is to increase use of green energy. We obviously have to pay attention to our costs. So it will probably be the way to adjust our emissions and reach our targets. We have also to be aware that today electricity emits more CO2 than the use of natural gas in nearly all the countries. Only France, because of nuclear production, in Brazil, thanks to hydroelectricity, have low emission factors. But for example, in Germany, the grid electricity today emits more than 600 kilograms of CO2 per megawatt hour, while gas is only 200. So we are looking at electricity, which will be greener in the next year, but also biogas and biofuel. I must mention hydrogen, which is really And phase 2 is not seen such a good alternative, because if you want green hydrogen, you need 5 kilowatt hour of electricity to produce 3 kilowatt hour of hydrogen. So it's better to use directly electricity in our furnaces than convert it to hydrogen and then to burn it.
So it seems that when it comes to reducing emissions in glass manufacturing, there are short-term goals and long-term goals. So what can glass manufacturers do right now to lessen their emissions? And what long-term strategies or goals should they be thinking about?
Well, on the short term, you obviously have programs to make our furnaces more efficient, and we're deploying an AI tool, ES3 it's called, to stabilize the furnaces. It works, it eases the work of operators, and allows up to 2% energy saving in our furnaces. Does not sound so much, 2%, but for each furnace is around 350 kilowatts of power. This tool will be extended to for half management, where we expect around 20% of consumption reduction. And then we also define roadmaps to optimize our energy consumption on compressed air and cooling air. To give an order of magnitude, we spend each year 40 million euros to produce compressed air and 28 million euros for cooling air. And we know we can save at least 20% of energy from better air. Will we make the necessary investment mainly in the 2 coming years because the paybacks are good? And in this field, we started some projects with AI to go beyond our internal 20% reduction target and use big data analysis and AI to further decrease our energy consumption with compressed air. The last point I wanted to mention is the production yield. Our energy consumption is mainly driven by pull tons, not by good tons. So all the defects that we reject go back in the furnace as cullet, but the energy we spend to melt raw mats in the furnace, to condition glass in 4 hours, and to form the container, to cool it down is lost. We ran 2 pilots of big data analysis to have an end-to-end approach and demonstrate the relations between some process parameters and the defects. The first pilot took place in Italy, and it was really successful, as we increased our yield by 1.7% and found some new relations that we didn't know about. The second pilot is currently going on in France, and thanks to AI, we already defined 4 new standards to improve our yield. And the last example I wanted to share is about quality, yield, and AI. Today, we are nearly blind on part of our regulations because video inspection machines are not able to label the defects very well. So we are working with our suppliers of control machines to label these defects. They use neural networks. They started to build their image database some years ago. We are helping them, and now machines reach more or less 90% of accuracy, but there are still some categories of defects where we lack images, which are the rarest defects, I'd say, and unfortunately, these rare defects are the most critical one. And so the system are not ready right now. This is the short term. On medium and long term, we also want to reduce the weight of container, but obviously we must grant the same mechanical characteristics. So we use simulation tools today, but we are still not able to design automatically the shape of the blank mold to get the best glass distribution in the final article. And this is a field where IA for sure will help us. And finally, to give just one example of what will happen when we'll change our energy mix, there is an initiative with Federation of European Glass Containers Companies to design an 80% electric furnace. The first simulations show that we will change tremendously the temperature fields in the furnaces, and that we will have to find new settings to mitigate the quality issues linked to the change. This is a new field of intense reflection and entertainment for our teams, but also a field where we definitively need help of AI system.
Yeah, it sounds like it. Like you could benefit a lot from it. So thank you, Fabian, for your answer. Liran, going to you. It sounds like AI can play a dramatic role in enabling glass manufacturers to lower their emissions. For example, Fabian mentioned that by reducing quality problems, that will lower the overall amount of production, which will directly reduce emissions. But how exactly would this work in practice? I mean, how can AI, for example, reduce these process-driven quality problems?
So it's pretty straightforward. Many of those process-related defects or process-related inefficiencies are not driven by a single parameter. Most of them are driven by multi-parameters, are driven by the relationships between the different machines and different process parameters. Those things are difficult for us as humans to see. It's too complicated, there are too many variables, there are too many moving parts. Artificial intelligence that really understands the process and has the subject matter expertise in the algorithm can identify those relationships and highlight them to the stakeholders, to the process expert or to the operator, and even recommend what they should do in order to prevent that from happening.
Thank you, Liran. So in conclusion, if I may sum this up, we've heard many fascinating perspectives and strategies about how to reduce carbon emissions while maintaining high standards of quality, throughput, yields, and so on. And the common theme is process efficiency. Liran, now that we've heard from both these top executives from the glass and cement industries, what is your take on this?
So process efficiency was always important, but what we've seen that many companies have picked up the low-hanging fruits. So they use the traditional methods, they use super smart people, and they're running those processes for many, many years. And now for many companies, they came into a kind of plateau where in order to reach the next improvement, it's already difficult. From one hand. From the other hand, we see continuous changes, even in efficient plants. A plant in the US that is now moving from coal to alternative fuels, a plant that is already running alternative fuels, moving to alternative raw materials, a plant that is slightly changing the manufacturing process to go more green, and so on and so on. So efficient plants need a powerful tool to take the next step, and plants that are inefficient are definitely looking for tools to run more efficiently, and plants in a change, in a journey, that are adding new recipe, new product, that are changing the part of the raw materials, that machines has different conditions. They need a tool to identify that and pinpoint what could be the root cause for those inefficiencies. And at the end of the day, today, process efficiency is the game of is the name of the game. At the end of the day, those are competitive industries, and if you can run your process more efficient than the competition, use your fuels and alternative fuels and raw materials, and produce better product, you will win the market.
Thank you, Liran. That's very educating and helpful. So thank you, Liran. Thank you, Marcus, and thank you, Fabian, and all our panelists. Now we will move on to the Q&A section of this event. You can submit your questions using the platform, and we'll return in just a moment to answer them. Thank you all.
Hello, we are happy to start the Q&A session. We are happy to hear your questions. And the first question is for you, Marcus. The question is, Jura considering production of so-called green cement from CO2, and is there a reasonable market for it? What is your view and goals for sustainability?
Well, such a thing like a green cement is difficult to say that you can produce it from CO2. What we actually have to do is we have to avoid generating CO2. And in order to do that, the cement industry and in particular also we at Jura CRH, we are trying to produce something that's called a composite cement. That means you lower the ratio of clinker in the cement. That means you're producing less of the clinker, which is actually in fact the CO2 emitter, which is an unavoidable emission we have. And this also leads a bit to the views and the goals for sustainability we have at Jura or at CRH. It goes in hand, you know, the cement industry is very, very energy intensive. So anything that reduces that energy consumption helps on the CO2 and on the decarb objectives. And as I said, we try to reduce the clinker in the cement, and we contribute to this circular economy by using actually a lot of alternative raw materials in the cement production, and also alternative fuels, so that we can actually save or preserve natural resources. So that's our view and our goals.
Thank you very much, Marcus. It indeed makes a lot of sense. The second question that is coming, are you using existing staff on these AI projects, or did you need to hire specific resources to deploy and execute? So usually with the right solution, you don't need to hire new team members. The Sibo solution is designed for the process experts and operators that today are on the production. There are other platforms in the market, usually not solutions, platforms that require data scientists, that require Python developers, that require team members that are usually not part of the average plant or average manufacturing company. So I think that the answer for this question is depends what tools, solutions, or platforms you're using. And with the Sibo solution, you would be able to do that with the team that you already have. Before I move into the third question that we have today, I would like to encourage the listeners to send more questions to our guests. The third question is, what is the full tech set? What is the full tech setup that would be needed to get results? Can it reuse existing sensors and hardware, or does it require new kit across the site? So when we look at the glass manufacturing industry and the cement manufacturing industry, and also the steel manufacturing industry, those industries has usually a lot of data. Now, the data does not cover 100% of the needs, but usually from this data, you can extract a lot of value. So from our point of view, usually the goal would be to monetize this existing data, to reduce the losses based on what is available. And only then, after a deep squeeze of the data that is currently available, we would go to add additional equipment. In many cases, it's not necessary, and in many cases, to address a specific problem is necessary. One of our recommendations would be not to collect data for the sake of collecting data, but only to collect data against a specific goal. So the approach is top-down. First, define your business need, define your goal, and only then make sure that the data that you need is available. When we look at the next question, does this replace other automation or work for the team? So usually the right solutions are not replacing existing automations, but it simply makes them better. To run a good automation on the production line, you need to understand the production line well. You need to identify the right thing that you would like to control. You would like to understand the boundaries that you would like to be at, and you would like to understand the relationship between the two, between the parameters that you are controlling. So a good control system is a system that obviously controls the line, but also deeply understand the set points, the data tags, and the relationships. And with a good artificial intelligence solution, you can define the control logic in a more efficient way. So usually the deep analysis of the line goes very well hand in hand together with an automation systems, expert systems, and closed loop systems. So we'll give it, another moment. And it seems that for now there are no further questions. And I would like to thank you all for watching the panel. And thank you very much for the questions.